Hello students, let's do set concepts exercise 6b. We are on page number 85 with question 4. State whether the given pairs of sets are equal or equivalent. Now what do we mean by equal sets? Now if I have one set with the elements A, B and C and I have another set with the elements C, A and B. Now if you look carefully, the elements in both the sets are the same. I have A, I have B and I have C in both the sets. So when two sets have the same elements, then we call them equal sets. Now what do we mean by equivalent sets? Now when two sets have the same number of elements, that is the cardinal number of this set. How many elements are there? 1, 2, 3. So the cardinal number of this set is 3. What about the other set? 1, 2, 3. The cardinal number of this set is also 3. When the cardinal number of the sets of the two sets are the same, we call them an equivalent set. Okay, so these two sets will be called equivalent sets because the cardinal number is the same. Now, what if the elements are different? Now here, if the elements are different, suppose I have 1, 2 and 3. So here we cannot call them equal sets because the elements are different. But look at the cardinal number. Here we have 3 elements, so the cardinal number is 3. Here also we have 3 elements, the cardinal number is 3. So when the cardinal number is the same, the sets are called equivalent sets even if their elements are completely different. Okay, so I hope you've understood what equal sets are. They must have the same elements. Equivalent sets are sets that must have the same cardinal number. So let's begin with the first one. Here we have two sets A and B. A has first four natural numbers and B has the first four whole numbers. So when you are given this way, the first thing to do is write it down as elements, that is in the roster form. Otherwise you won't be able to understand from this, isn't it? So let's write down what actually the elements of A are. First four natural numbers, that is 1, 2, 3 and 4. First means natural number, the first number is 1. So we have 1, 2, 3, 4, that is set A. Now set B is the first four whole numbers. Whole numbers begin from 0. So these are the elements of set B. So if you look carefully, the elements of set A and set B are not all the same. Here we have 0, we don't have it there. In A we have 4, we don't have it here. So we cannot call them equal sets. But look at the cardinal number. How many elements are there? 1, 2, 3, 4. There are 4 elements here. Here also 1, 2, 3, 4. We have 4 elements. Since the cardinal number is the same, or since the number of elements in both the sets are the same, we call them equivalent sets. So these are equivalent sets. And what's the reason? Both have equal number of elements, though the elements are not the same. So it doesn't matter whether they are same or not as long as they have an equal number of elements. Question 2. Set A is set of letters of the word follow and B is set of letters of the word wolf. So first let's write down the letters and see. So set A, now we have to write the letters of this word follow. Remember, we cannot repeat. So what will we have? We'll have F, O, L. I cannot repeat L. I cannot repeat O and I have W. So F, O, L, W. Now let's write it down. So we have it here. F, O, L, W, leaving, putting a comma after each. We have 4 elements. Now set B is set of the letters of the word wolf. So we have W, O, L and F. So let's write that down. W, O, L and F. Now here if you see, you have the same number of elements, isn't it? We have 4 elements in both in A as well as in B. Now let's look at the elements itself. Here we have F, here also we have F. O, O, L, L, W, W. We have the same elements. So when the elements are the same, we call them equal sets. Now we can also call them equivalent because the number of elements are the same. So we're going to first call them equal sets as both have the same elements. Now if you're asked for true or false whether they are equivalent sets, it is true. They are equivalent sets also because the number is the same. Next one, Set E is even natural numbers less than 10 and O is odd natural numbers less than 9. So E, even natural numbers less than 10, let's write it down. It will be 2, 4, 6, 8. We're talking only about the even numbers. Natural numbers, we can't add 0 and they should be less than 10. So we have this. Now O is odd natural numbers less than 9 and that will be 1, 3, 5, 7. As you can see, the elements are completely different. But look at the cardinal number. How many elements do we have? 1, 2, 3, 4. Here, 1, 2, 3, 4. So the number of elements is the same. So we call them equivalent sets. So they're called equivalent sets because both have equal number of elements, though the elements are not the same. Question 4. A is days of the week starting with the letter S. So let's write down the days of the week starting with the letter S are Saturday and Sunday. So there are two elements here and both start with the letter S. Now set B is days of the week starting with the letter T. So that is Tuesday and Thursday. So as you can see, the elements are completely different. But look at the cardinal number. There are two elements here and there are two elements here. That means they are equivalent sets. So equivalent sets because both have equal number of elements, though the elements are not the same. Question 5. M is multiples of 2 and 3 between 10 and 20. That means you need to write the tables of 2 which are between 10 and 20 and the tables of 3 which are between 10 and 20. So let's write that first. So M will be 12, 14, 15, 16 and 18. How did we get that? Multiples of 2 between 10 and 20 is 12, 14, 16 and 18. Multiples of 3 between 10 and 18 is 3 5s are 15, 3 6 are 18. So these are the elements of set M. Now look at set N. They are multiples of 2 and 5 between 10 and 20. So let's write that down. So multiples of 2 will be 12, 14, 16 and 18. Then 5 multiple of 5 between 10 and 20 is 15. So what do you notice here? Can you see the elements are the same? I have 12, 14, 15, 16 and 18 in both the sets. That means these are equal sets as both have the same elements. Can they be called equivalent sets? Yes, because they have the same number of elements also. Question 6. P is prime numbers which divide 70 exactly and Q is prime numbers which divide 105 exactly. Now, how do we get that? So what we can do is let's find the prime factors of 70 first. So prime factors of 70 will be, now divide this by 2. 2 into 35 is 70. Then you can go to 5. 5 sevens are 35. Then we can divide it by 7. 7 ones are 7. So the prime numbers which divide 70 exactly are 2, 5 and 7. That is set P. Now, what is set Q? Prime numbers which divide 105 exactly. So let's divide 105 with the prime numbers and see. So 105, I can divide this by 5. 5 twos are 10, 5 ones are 5. Now I can go to 3. 3 sevens are 21, then 7 ones are 7. So here what are the prime factors? Again 3, 5 and 7. So Q is 3, 5 and 7. So the elements in P are 2, 5 and 7. In Q it's 3, 5 and 7. They are not the same because I have 2 here and 3 here. So I cannot call them equal sets. But they have the same number of elements. The cardinal number here is 3. The cardinal number here also is 3. So what do we call them? Equivalent sets because both have equal number of elements. Question 7. Here we have set A with squares of whole numbers from 0 to 4. So let's write down the squares of these. So 0 square will be 0, 1 square 1, 2 twos are 4, 3 threes are 9, 4 fours are 16. Remember when we say square we are multiplying the number by itself. So here we have the elements of set A 0, 1, 4, 9 and 16. And set B, we have these numbers 16, 9, 4, 1, 0. If you look carefully, we have the same elements 0, 1, 4, 9 and 16. The elements are the same. So when elements are the same, we call them equal sets. Okay, as both have the same elements. And we can also call them equivalent because they have the same number of elements. Question 8, we have set E. It's already given to us. Let's write it down anyway. Set E, these are the elements. And set F, what are the elements? It's not given. We are going to write. They are even natural numbers between 6 and 18. What are all the natural numbers between 6 and 18? After 6, 8, 10, 12, 14 and 16. Let's write it down. So that will be 8, 10, 12, 14 and 16. What do you notice here? The elements are the same. So when the elements are the same, we call them equal sets. They're called equal sets as both have the same elements. Question 9. A is letters of the word superstition. Now, when we write the letters, remember, you must not repeat. So I can write S-U-P-E-R. S has to be taken off. T, I remove T. I don't write I, O and N. So let's write all these letters. So S-U-P-E-R-T-I-O-N. We have not repeated anything, isn't it? Okay. Now, set B is letters of the word jurisdiction. So what now do we have? J-U-R-I-S-D-I. We must not try, take it off. C-T. I again is repeated, take it off. O and N. We've removed only the I's that are repeated. So what do we have? We have these letters. Now, as you can see, they are not the same. Letters are different, isn't it? I have S and S, U and U, P, but I don't have P here. So they are not the same. But let's count and see. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 elements here. Now the other one, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So here we have 10 elements. So 9 elements for set A and 10 elements for set B. So you can't call them equivalent sets also, isn't it? So here these sets cannot be called equal, neither can they be called equivalent. So we have to leave it at that. We cannot call them equal or equivalent. Question 5. Examine which of the following sets are the empty sets. So here we've been given 4 sets. We have to see which of these is an empty set. Now look at the first one. The set of triangles having 3 equal sides. Now if you have to have a set like this, you have to have triangles having 3 equal sides, and as you can see, all triangles have 3 equal sides. So in this set, there will be elements. Okay, so this is not an empty set. So the first set is not an empty set because this set has triangles having 3 equal sides. Second question, the set of lions in your class. Now, in your class, do you think there will be lions? There won't be, isn't it? So this set is an empty set. So let's write that empty set. Question 3, this is given in the set builder form. Let's find what the elements are. So here it says x is such that x plus 3 is equal to 2. So let's find out this. Let's solve this. X plus 3 is equal to 2 and find out the value of x. X plus 3 is equal to 2. So this is an equation. So now we are going to solve for x because we need to find the value of x because x is the element in that set. So x will be 2 minus 3 because we are transposing this 3 from here to the right hand side. It will become minus 3. So now we are going to find the value of x. X is equal to, now 2 minus 3, when signs are different, this has a plus sign and 3 has a minus sign. Signs are different. So put the sign of the bigger number and subtract. 3 minus 2 is 1. So the value of x is minus 1. Now let's read the rest of the question. So now we found that x is equal to minus 1. But here look at this part. It says x belongs to n and n stands for natural numbers. So x belongs to n, whereas x here is minus 1, which is not a natural number. That means this set is empty. There is no element here. X is minus 1, but since minus 1 is not a natural number, we cannot put it in that set. So there is no element in that set. So this set is an empty set. Question 4. P is equal to x is such that 3x is equal to 0. So here also let's find the value of x. So what is given to us? 3x is equal to 0. So this is an equation, linear equation. We're going to find the value of x. We're going to say x is equal to 0 divided by 3. Division, because here 3 is multiplication. So when we transpose it to the right hand side, it becomes division. That's how we got 0 divided by 3. And how much is 0 divided by 3? 0 divided by 3 is 0. That means x is equal to 0. So in this set, you will have 0 inside. That means this set is not empty. There is one element inside. So this is not an empty set. So the answer is not an empty set. Question 6. State true or false. So we've been given these statements. We're going to say whether these are true or false. All examples of the empty set are equal. So that means if you have one empty set here and another empty set here, can you say that they are equal? Yes. Because there's no element here and there's no element here. So this is equal. So these two sets are equal. So this statement is true. Next statement. All examples of the empty set are equivalent. What are equivalent sets? The number of elements should be the same. That is, the cardinal number should be the same. So let's draw two empty sets here. So I have one empty set here and I have another empty set here. Okay. Now in this first empty set, what is the cardinal number? There are no elements inside. Isn't it? There's nothing inside. So the cardinal number of this set is 0. The other set also, there's nothing inside, so the cardinal number is 0. That means there are no elements. So these two sets both are 0 and 0. That means they are equivalent sets. That means this statement is also true. Next question. If two sets have the same cardinal number, they are equal sets. That's false. If they have the same cardinal number, what are they called? They are called equivalent sets. So this statement is false. So let's write that. False. Next one. If n of A, what does n stand for? Cardinal number. If the cardinal number of set A is equal to the cardinal number of set B, then A and B are equivalent sets. That's true, isn't it? Because the cardinal numbers are the same. If the cardinal numbers are the same, they are called equivalent sets. So this statement is true. Next one. Set B is equal to x is such that x plus 4 is equal to 4. Then B is the empty set. That means we have to find what x is. Okay, so let's find out the value of x. So here it is x plus 4 is equal to 4. So let's write that x plus 4 is equal to 4. Linear equation, we can find the value of x. X is equal to 4 minus 4. Because I have transposed this plus 4 to the other side, it's become minus 4. So what is the value of x? X is equal to 0. That means inside set B, what do you have? You have 0. So what does this statement say? The statement says that if this is the set, then B is an empty set. Is that true? B has 0 in it because X is 0. So can B be an empty set? No. Okay, now if I draw a set like this and I put 0 inside, is this an empty set? It cannot be an empty set because there is an element 0 inside. So here we found out that x is equal to 0. That means in that set we have 0 and it is not an empty set. So this statement which says B is the empty set, that statement is false. Question 6. The set of all points in a line is a finite set. Now, if you have a line, there are many points in this line. If the line is made up of many points, can you count the number of points? You cannot. So here it says it is a finite set. That means you can count, which is wrong. It is an infinite set. You cannot count. So this statement is false. Next question. The set of letters in your mathematics book is an infinite set. Now here we are talking about a book. So in that the number of letters will be countable. If there is a need to count, you can count. It's not that the number of letters will keep going on and on and on. So it is not an infinite set, it is a finite set. So this statement is false. So we can write that. Next one. If m is equal to 1, 2, 4 and 6 and n is such that x is a factor of 12. Okay, now we have to find the factors of 12. We have the elements of set m. We don't have the elements of set n. So let's write the elements of set n and see whether it's the same. So factors of 12. 1 into 12 is 12. 2 into 6 is 12. 3 into 4 is 12. So these are all the elements of set n. So set n has 1, 12, 2, 6, 3 and 4. Whereas set m has 1, 2, 4 and 6. There are only 4 elements here. Whereas here we have 6 elements. So the question is, statement says that m is equal to n. Are they equal? They are not equal. So this statement is false. Question 9. The set of whole numbers greater than 50 is an infinite set. Greater than 50 will be 51, 52, 53, which will go on and on. So it is an infinite set. So this statement is true. Next one. If A and B are two different infinite sets, then the cardinal number of A will be equal to the cardinal number of B. Yes, isn't it? Because A and B have elements that cannot be counted. So that will be endless, limitless. So the cardinal number of both the sets will be equal. So this statement is also true. Question 7. Which of the following represent the null set? Okay, so here we have different symbols. Now, which of these represent the null set is the question. The first one is the representation of the null set, because you can write a null set like this. You can write it like this also. So this is representing a null set. So the first one. Second one, no, because there is one element inside. So there is an element inside, so you cannot call it a null set. The set has one element, cardinal number is 1. The next one is 0. It is not in the form of a set, so we cannot include this also. Now the third one is an empty set. We are putting the curly brackets and there's nothing inside. It represents an empty set. The last one is we have put curly brackets and we have put the symbol of the null set inside. That means in this set there is one element. This element is there inside the set. It's not empty. This is empty. Whereas this one has one element in it. So this cannot be called a representation of a null set, the last one. So it's only the first one and the fourth one. So these are the two that represent the null set. So this is one symbol. This is the other symbol to represent the null set. So with this, children, we come to the end of this exercise. Thank you, children.